Good day, everyone. So today's video will be one of my favorite series. I'm going to present the roadmap for the topic of electrostatics. Before we begin, I would suggest you to at least get familiar with all the theory about electrostatic, which I've covered in my last 4 videos. So let's get started. So first thing is about the point charge. So we have learned a lot about the point charge. That when we have a positive charge, there is electric flux produced around the point charge. So we are given with Gauss law that define the electric flux is equal to the total charge divided by the permittivity of the medium. So another definition about flux is the product of E and A. So using both this formula, so we could get the formula of E equal to Q divided by 4 pi epsilon R squared. So next is about the Coulomb's law that define the electrostatic force between 2 point charges, which is proportional to the product of charges and inversely proportional to the square of R. So looking at both force and the electric field strength, so we can relate both of them using the formula of force equal to QE. So next thing we're going to talk about, we are doing some work to move the point charge, another point charge, from one point to another point against the electric field produced by the source charge. So by integrating the force respective to F, we can get the formula for the work done. And then we learn about the electric potential, which defined as the work done per unit charge. So we could derive the formula for the electric potential equal to Q divided by 4 pi epsilon R. So now we look carefully on E and B, which we have learned before. So by differentiating V with respective to X, we can get the formula of electric field strength. In the other way around, we can integrate the E respective to the distance, we can get the formula for electric potential. So lastly is about the electrical potential energy that is defined as the work done to move the charge. So we are given with the formula of U equal to QV. In the end, you can get the formula for U equal to QQ divided by 4 pi epsilon R. So you can notice that W and U are having the same formula. So this is because that the energy is conserved. So the work done, we say that the force applied on the point charge will be converted into the electrical potential energy that is stored in the point charge. So next thing, we're going to talk about the roadmap of electrostatic for the two parallel plates. So you should have seen about the parallel plates in a lot of questions in trial papers or maybe in your textbook. So first, we have learned that electric field is produced between two charge plates, which is connected to a potential difference. So first, we need to be sure that Coulomb's law doesn't apply here, since the Coulomb's law only talk about the electrostatic force between point charges. So we remove them from the roadmap and we do a revision on the overall roadmap again. So first, we start with the Gauss law. So electric field strength will be derived as equal to sigma divided by epsilon, where sigma is the charge density on the charge plate. So you might recall back that the electric field that we have derived before is the sigma divided by 2 epsilon, and that formula is applied to an isolated charge plate. So to understand about the derivation of E for two parallel plates, I will provide a link below for your own self-study. So the force can be obtained by using the formula of F equal to QE. And then we need to know that the electric field produced by the charge plates is actually constant. So doing the differentiation or the integration between E and V, we will say that it's no longer significant anymore, but still applicable. So next, we're going to connect the force back to work done again using the formula of force multiplied with the distance, which you have learned in the STPM physics. So again, we use the definition of electrical potential, which is equal to work done divided by Q. We will revise the formula of V as E times D. So from here, you also could get that E is the ratio of the potential difference and the distance between the charge plate that I've explained in the second video. So, and then about the electrical potential energy, so we would just use the formula of U equal to QV. So here I will leave a question for you. So please prove that the work done is equal to U. So it is a simple task, which I believe you can do it. So if you couldn't get the answer, maybe you can leave a comment below so I can answer them in the comment section. So after we learn everything about the formula, so next thing that you might encounter in the questions is about the motion of the point charge. So we have another point charge that appear in the electric field. So first that we have learned the electrostatic force that apply on the point charge. So it is equal to the MA. So F equal to MA equal to QE. So from here, we could derive the formula of the acceleration that caused by the electrostatic force on the point charge. So another thing that you might see in the question is about the conversion of energy. So you have learned about something called the thermal ionic emissions and also the production of cathode ray in your STPM physics. So this is about the conversion of energy from the electrical potential energy to the kinetic energy. So from here, we could derive the formula of the velocity of the point charge when it is moving out from the electric field. So regarding this matter, so I will prepare a video in future to discuss further about it. So up to this point, you should have understood better about the link between all the puzzles in this topic. So I will suggest you to rewrite all the formula again by yourself. So on the other hand, I provide a link in the description below to download the picture of the roadmap. So before we end the video, so I would like to do a survey to get your feedback on my video and also the teaching progress in your school. I wish to know the topics that have been covered by a school teacher so I can plan my future contents. So kindly fill the survey form. I will be very appreciating your feedback. So that's all for today's discussion. You can leave a like and share the video if you like this series. So see you in the next video.